This is Algebra 1B lesson in geometry, specifically on similar triangles. And when we talk about similar triangles, we don't mean that they just kind of look alike. There is a specific proportion that we need to make sure we're looking at. To begin with, when we're naming a triangle, for instance, triangle ABC, we use the three vertices to name it. Every triangle has three sides and three angles that are mentioned here. Let's look specifically at the similar part. So if we're told that triangle DGP is similar to triangle KLM, I could also write it like this, which means DGP in order is corresponding to KLM. I can look at my drawing over here, and these two segments, DG and KL, divided by each other, are in the same ratio as GP. GP divided by LM, those two segments, and that's in the same ratio as PD divided by MK, those two segments. It also means all the corresponding angles are equal. So if I look at my first letters, D and K are going to be equal to each other. On the drawing then, I could say this angle down here is the same size as that angle. The second letters, angles G and L would be equal to each other. And the third letters, P and M, would be equal to each other. For an example, we're told that triangle ABC is similar to triangle DEF. I already have this information for the first triangle. And A is the right angle, which means D has to be the right angle. AB is the short side, DE is the short side, and then the long leg is AC, just like it is DF in the other one. All right, let's look at a few more examples here. It says, determine whether each pair of triangles is similar and justify your answer. So one of the things that we looked at before was, in order to be similar, all the corresponding angles must be equal. So in this first example, 30 degrees and 30 degrees are equal to each other. And remember that there's 180 degrees in a triangle. So in this first one, 120 plus 30 is 150. If you subtract that from 180, that means that there's 30 degrees left over for this one. So it means this angle must be equal to that angle. And lastly, in this bottom triangle, we subtract 180 minus those two, which leaves us with 120 degrees for this third angle, which is equal to that one. So that means yes, these triangles are similar to each other. In the next example, we have angles of 60 and 60 corresponding with 90 and 45. Neither of those pairs of angles match up at all, so there's no way those triangles are going to be similar to each other. I'd encourage you to pause the video at this point, try to work through those other ones, and then when you're ready, go ahead and restart the video and you can see how well you did. Of these four examples, this first one, this number 3, is probably the hardest one. One thing I noticed is that two pairs of angles are already equal to each other. So no matter what size they are, the amount that's left over for this third angle has to be the same in both of them. So actually, yes, this one is going to be a pair of similar triangles. In numbers 4, 5, and 6, I subtracted the two known angles in each case from 180 to figure out the third angles. And in this example, we now have the biggest angles at 110, the medium-sized angles at 40, the smallest at 30, so this is a yes. Next one, have three pairs of equal angles. The last one, you don't have any equal angles, so this one is definitely a big no. Next one, we're told that triangles ABC and AED are similar to each other. And we're given all this information and we're asked to find the length of BC. So here is what our situation looks like. And I know corresponding sides based off of the letters. For instance, letters A and C are in the same spots as A and D, so those two segments have to be corresponding to each other. Just like segments BC and ED, these two sides have to be corresponding to each other. And because these triangles are similar, we can set up this proportion. 300 over 25 is equal to x over 7. We have this. And in a proportion, what you want to do is cross multiply to solve for x. So we did that, divide by 25, and you get that x equals 84. All right, moving on. There's 4 examples here, all using the same drawing. You're told that these triangles are similar to each other, so I'm going to go to colors here. The greens are corresponding to each other. Let's get the pinks corresponding to each other. And also we have these yellow ones corresponding to each other. And the numbers were given in number 1 say that C is equal to 15, D is equal to 8, E is equal to 6, and F is equal to 10. So as I look at these segments, I know that because of their location, 15 is corresponding to 10, and then the pinks are corresponding, so I could say that's equal to A divided by 8, the pink divided by the pink. And notice I'm going from the left triangle to the right triangle. This is also going to equal to the yellow over yellow, that would be B over 6. Now I'll take 2 of these at a time, kind of ignoring this third one for a minute. 15 times 8 is 120. 10 times A is 10A. Divide both sides by 10, and I get A equals 12. So there's one answer. Then I'm going to ignore this middle one. 15 times 6 is 90. B times 10 is 10B. Divide both sides by 10, and I get that B equals 9. So there are the unknown sides for problem number 1. What I'd encourage you to do then is try example numbers 2, 3, and 4. If you're doing this on OneNote, you can just erase those and put the new numbers in there. Otherwise, just draw the triangle over again. But go through those examples and you can check back your answers in a moment. All right, so here are the examples for those problems. Number 1 was already done. Here is the work for problem number 2. Those are our answers. The work for number 3, those are our answers. And number 4, here's the work, there's the answers. So again, hopefully you've worked those out and you can check to see how accurate you were. If you didn't get those correct, you can see how I set them up. The drawings were all the same as the original, and I set up those proportions in order to solve for the unknowns. Next set of examples says determine whether each pair of triangles is similar. And similar to what we had before, we're looking at comparing the 3 angles. In this first example, none of them are equal to each other. And the next one, we're looking at the corresponding sides. The smallest side of 3 compared to the smallest side of 5. The medium size 4 compared to the medium size 12 compared to then hypotenuse of 5 with 13. Are we saying, are these equal to each other? Example, 3 divided by 5, is that equal to 4 divided by 12? It's not, so there's no way that those triangles are similar. Numbers 10 and 11, again, we're comparing sides. So we have a 4, 8, 16 compared with a 10, 20, 40. So you're looking to compare the smallest sides, 4 over 10, the medium size, 8 over 20, then the largest sides, 16 over 40. And as I look at this, it seems like all those proportions are the same. 4 divided by 10, 8 divided by 20, and 16 divided by 40 all give us the same decimal. But what actually ends up happening here, and this is kind of a trick question, is that these numbers don't make sense. You can't have a triangle with the longest side of 16 and then a side of 4 and a side of 8. They wouldn't even make a triangle, so that's why this one is actually no. The next one, we have 90-degree angles, which are the same, but this 30 degrees would end up being compared with this 31 degrees. They're not the same, so those triangles are not going to be similar either. All right, and then here's the last set of examples. This drawing that we're given up here is the drawing that applies to all of these triangles. So you could just redraw the triangle every time. I'd encourage you to work through each of these and then check your answers. In just a minute, I will display the worked out solutions for all of these problems. But I'd copy down these problems, try them as best you can, and then check the work to see if you got the answers correct. So pause your video and see what you can do. All right, and here are those solutions, starting with numbers 12 and 13. I have the drawings labeled for number 12. Here are the proportions set up. You can cross multiply. In other words, looking at just these first 2 fractions, 2 times p is equal to 5 times 4. And then solve that equation to get p equals 10. To solve for t, you could say 2 over 4 is equal to 7 over t. cross multiply, we get t equals 14. Here are your solutions for numbers 13 and 14. Number 13, I used colors again for those. M is equal to 3, K is equal to 8. Here are the equations I used. For number 14, I have my drawings, I have the proportions. There's the values, the answers for R and H. And number 15 uses some good radical work that we did in the last unit. Here are all the corresponding sides lined up, and if we cross multiply again, we can solve for P and we can solve for K.